Welcome to the new shop. Since the last series of videos, I've made some major changes. The Tormach was a good machine and it served me well. I made several thousand successful parts with it, made many NQALHAs, made many prototypes, and generally it was a good machine, but you know, I just outgrew it. Its limitations and its quirks just became too annoying, so I got myself a real one, a Haas Mini Mill 2. And just in case anybody is wondering, yes, it is possible to get a Haas Mini Mill 2 into a residential garage. I actually set up a couple of cameras when the machine was being installed. I didn't do any kind of complex camera work. They were just set up on tripods and I just let them run, so probably all the details that you might want to see won't be there. But coming up right after I finish talking, I'm going to show a little bit of how the machine was actually brought into the garage and how it was set up. And in the next series of videos, I'm going to be doing NQALHA Production Run 5 on the Mini Mill and going to be showing some of the work that I'm doing to learn to use the machine. Of course, learning to use a machine like this is a rather complex thing, and I'm not going to show every painful detail of the learning process, but I'll show a little bit to give you a kind of a flavor of what's going on. So mostly this is an amazing, excellent machine, and I look forward to it making excellent parts faster and more precise than ever before. I was, however, unpleasantly surprised by one of its limitations that I was not expecting at all. It has a 20 position tool changer, and in the Tormach I can have a tool library of 60 tools and load up 10 at a time, and the machine takes care of it. I say, okay, put in tool 41, and it puts it where it fits, and I don't even have to be concerned with which position it's in. Well, the Haas has a very serious limitation, that it has a 20 position tool changer and can only use 20 tool numbers. My tool library is 50, 60 tools. So I ended up having to do a number of workarounds to accommodate this, including writing a piece of custom software to run after the post processor, kind of a post-post processor, to modify the tool number to match the carousel and the length offset number to manage the tool that's actually in the carousel. I also created this rack for my new tool holders, and the rack is organized in such a way that it makes it harder to make a mistake, because I don't like doing manual things that are error prone because I make mistakes. And on this machine, stuff happens so fast that if I got the wrong tool in the carousel, it's going to be really hard to stop it before it breaks something. So the scheme that I'm using now, 20 tool changer, 14 of the tools I consider to be the common tools. The tools I use all the time. They stay in the tool changer pretty much forever and never get removed. This includes the probe, the Renishaw probe that I use for setting a work position and for inspection. Leaves 6 tools left that can be mixed and matched as the job requires. So I've divided, I've looked at the parts that I make and looked at the combination of tools that are used to make each part and grouped them into 4 standard sets of 6, and then put some tape on the tool holder so that I've got my sets of 6 here, the set 1, 2, 3, 4. Then I've got my infrequently used tools that I call the special set, that are inserted one at a time as necessary. So the custom post processor that I wrote creates a setup sheet that tells me what set I'm using and what tool number goes in what slot number. So when I prepare to make a part, I can look at the sheet, load the carousel correctly. If I ever walk up to the machine and wonder what's loaded, I can look at the rack and say, oh, I see holes in position 1, so therefore set 1 must be loaded. So I'm going to stop talking now and kind of edit in the installation video. And then after the installation video, I'll probably do a little bit of probing demonstration and a little bit of cutting demonstration. And then in the next video, I'm going to start NQALHA Production Run 5. Exciting times are ahead. It's a good thing we have a really big driveway because it makes a lot of room available for trucks to come in. There's the Haas technician right on time, and the forklift is unloading from the truck, and yes, they did bring the correct size truck to get down our road. The riggers are doing an excellent job, and so is the Haas technician. The installation went extremely well. Everybody was about as professional as you could imagine. There's a lot of packing material and a lot of things that need to be disassembled. The machine is very, very well packed and very well protected, and it arrived completely undamaged. So I'm just standing around watching now. Get the machine on the forklift. Now I was wondering if it was going to fit through my door, and as soon as they tried putting it through the door, well, they discovered that no, it doesn't quite fit. But I was prepared for this. There's a 2x6, just a trim piece, not structural, that I was prepared to remove and didn't want to remove it unless it was necessary. So there I am up there with the Sawzall, and doing this in real time. The rest of it is sped up, so taking out the trim piece. I wanted to avoid this if possible, even though the trim piece is not structural. It's always nice to do as little modification of the house as is absolutely necessary, but needed that extra inch. Also, the top part of the machine, a lot of the sheet metal parts, there's a resistor that is on the top for slowing the motor down, and a cable management device. That's all been removed. It was removed at the rigger's shop before the machine was loaded, and so it's been reduced down to the lowest that a mini mill will go. I've actually heard rumors that they can go lower, but this is as low as it was for me. So now the forklift is barely clearing the ground and the machine is barely making it in. It actually, and of course there's eyeballs everywhere. The rigger is watching, the tech is watching, I'm watching, everybody's being very, very careful. The top part of the machine actually kissed the top structural frame of the garage door. No damage, no scraping, but boy, it was close. And yes, the machine made it in. I moved my Bridgeport kind of on my own with a helper and a rental forklift, and it was pretty scary for somebody who's never done it before, and I was so happy to see professional riggers who knew what they were doing, properly prepared with all the right equipment. So taking some pictures here as the machine comes in. After it got into the garage door, they put it on a pallet jack, and not just a regular pallet jack. They actually had an 8,000-pound special super duper pallet jack. And so now they're jacking it up back to high-speed video mode. I cut a hole in my ceiling and rerouted some pipes in order to make room for it. So there it is in place. Had to temporarily hook up the power, temporarily hook up the air. The Haas tech is busy getting everything ready, putting it all together. There was a bit of an uncertainty about how it was hooked up to the electrical. I guess the Haas tech kind of forgot which two. This is a single-phase hookup, and he kind of forgot which of the two connections, because the controller box is wired for three-phase or single-phase, and he kind of forgot which connections to hook up, and so we had a bit of uncertainty while we're figuring out which connections to connect. But eventually connections were made, air was made, user interface comes up, and then the technician starts reassembling. All the parts that were taken off at the rigger's office were found and reassembled, and of course he's on the phone with his support people asking questions, because as good as he is, he doesn't know everything, and when he had a problem he would ask his buddies, hey, what do I do here? What do I do there? And everything went extremely smoothly and no problems at all. I'm so glad to be working with competent professionals. I cleaned everything out of the shop, totally moved everything out, moved out the car, moved out all the tool racks, all the toolboxes, all the other tools. Everything was clear to give them the best possible work area. And little bit by little bit, he's working on it, scraping off the thick layer of protective lube, assembling parts, doing a rough and preliminary leveling. Of course, after the machine was fully in place, he did a very precise leveling with a machinist level to within a few thousandths of an inch. And it actually surprised me to learn that even a small amount of out of level can twist a heavy cast iron frame. Doesn't twist it much, just a fraction. But when you're setting up a precision machine tool, a fraction matters. So little bit by little bit, the Haas tech is working, the riggers have gone home. Lots of work to get the machine ready. The first parts I'm going to be making are a new set of soft jaws for the vices. The old set of soft jaws has been used for a long time. It's got lots of little mistakes, a lot of drill throughs, they're kind of dinged up, and I thought, new machine deserves a new set of soft jaws. So because I was totally focusing on getting the job done and really didn't want distractions, the first operation of drilling and counterboring the holes wasn't shown because it was the first parts I ever made on the machine. I wanted to pay attention to the machining and not get distracted by making a video. So in this segment, I've got the GoPro inside the enclosure, and I'm going to attempt to do a video on actually cutting some chips. And I'm going to be putting the ledges on the soft jaws. I make a number of different sets of soft jaws with different depth ledges. So if I'm cutting a piece of 3/8 material or 1/2 inch material, I have a rather large ledge, and if I'm cutting a thinner material, I have a smaller ledge. So I'm going to be making a number of different ledges on the soft jaws. And the first thing that I do to get started is use the Renishaw probe to figure out where the corner of the material is. So I've already set it up and kind of ready to go, but I'm going to demonstrate a little bit more how it's set up. The probe is commanded using G-code, just like any other program. And because I haven't yet integrated the probing G-code into my part programs, I'm using the Haas kind of like pre-built-in programs where there's a lot of manual operation going on, and it's like you jog into position, get the probe pretty close to where you want to probe, and then run the program that they supply. And so I'll show how to do that, but later on, as I get more comfortable with writing probe programs, when I'm actually making parts in production that I need to probe, it'll all be part of the toolpath program, and the probe will be totally unattended, totally automatic. But to start out here, the way this works, you activate the handle jog, and let me get the machine. So, okay, now I've just loaded the probe, and I want to measure this corner because this is going to be my 0 point. This face, this top, and this side. So the canned program, the pre-programmed jog that they supply with the machine, you basically hand jog using the jog handle and get the probe roughly over where you want to probe, and then configure. There's like a setup wizard that you configure the probing cycle to say, okay, go down 1 inch, and if you don't find a surface, flag an error. So I've got roughly the tip of the probe is somewhere around a ½ inch off the surface. Looks good to the eyeball. I'm going to go into MDI mode, and we run the program. Start up the probe, probe the surface, and now the Z position is set at the top surface of the aluminum. So now, back over to handle jog, and in order to set the corner position, I kind of roughly line up the probe kind of sort of where the corner is, and then go over here to the user interface, which I'm kind of getting a little familiar with how this thing works, but still, you know, it's a new piece of equipment. So this will be considered corner 1. They have a graphic on screen. So I'm going to say X distance is going to be, I don't know, 0.3. Y distance 0.3. Z distance, I'm going to call that -1. And output to MDI, go into MDI mode, and now hopefully with any luck this will in fact probe that corner. And there we go. So now the machine knows where this corner is, and then I'm going to turn the camera off and go in and do some toolpath and make sure that my toolpath is correct and that the simulation is correct, and then load up a cutter and see if I can make some chips without breaking anything. So, see you later. Okay, I've got a toolpath here. I'm going to get the probe out of the way and get the vise a little closer. So I'm going to put a spacer in here so I can do both sides of the jaws. I'm going to be cutting a 300 thousandths deep ledge, and especially in the early days of using this thing, it's always terrifying. This thing, it's an amazing machine, but hey, everything goes really fast. So I'm looking here to make sure that everything is correct. Eyeball examination of the G-code. And yes, it's looking like things are correct. And because I'm new and I don't really have this thing under control yet, I'm going to be as careful as I can possibly be. Going to restrict rapids to 25%. Going to put it in single step mode and go through a similar kind of process to the process that I used with the Tormach, which is running in single step mode with a reduced rate of rapid feed, and also pay attention to the distance to go numbers in between each step so that I can see in advance if it's going to go too far. So let's run this pig. Okay, correct tool is being loaded. And single block mode. Hand on the stop button. Looking good. Coolant on. Pre-feed correct. (7,000 RPM, 50 inches per minute. I suspect I can go a lot faster. This machine, I ordered it with the 10,000 RPM spindle, and I plan to use high-speed machining techniques as soon as I learn them. There's a lot to learn, and I'm sure that I'm going to end up breaking some cutters and making some mistakes, but hey, let's get out of single block mode, 100% rapid. Let's get, and this is an old Tormach program, so I'm doing it in multiple passes. I know I don't need to do it in multiple passes on this machine because it's got the rigidity. So all looks well. How about those rapids? This machine is going to be so much faster. Leaving out the fact that it's more rigid and has a higher spindle speed and will cut a whole lot faster, the rapids are insanely fast. The tool change is much faster, 3 or 4 times the speed of the Tormach. So exciting times are ahead. And that concludes today's video. The next one in the series is going to be NQALHA Production Run 5. Exciting times are ahead. See you later.